Hey guys, today we're going to be doing dimensional analysis. This will be example 1 of 2. Stay tuned for example 2. Okay, so dimensional analysis is an analysis that uses the fact that when you set terms equal to each other, okay, things on either side of the equal sign have to be expressed in terms of the same fundamental quantities. Things like mass, time, length. Okay, there are 7 standard base units for SI units, and that's what you work with. Every other unit can be derived from those 7. Okay, examples would be seconds for time, kilograms for mass, etc. Okay, so let's do this problem. The speed v of an object is given by the equation v equals bt cubed minus ct, where t refers to time. What are the dimensions of b and c? Okay, so whenever you do dimensional analysis, you always take the equation, rewrite it, and then below that, you want to write it in terms of square brackets because square brackets are what are used for dimensional analysis. Now, other than missing a coefficient, like a number you multiply by, dimensional analysis always helps you see the relationship between different quantities on either side of the equal sign. Okay, so getting started, we're looking for the units of b and c. We know v is speed, and the SI unit for speed is meters per second. Notice how I'm writing it there in square brackets. Okay, so I'm going to go ahead and replace the right side also with square brackets. So b, t is cubed, minus c, t. All right, so t has units of seconds, okay? So I can fill that in on both sides. Now, because we have meters per second on the left, and we have a difference on the right, both terms have to come out to having units of meters per second, right? Because meters per second minus meters per second is meters per second, okay? The only thing is right now you've got here on the left seconds cubed. So the question becomes this: what do I multiply to seconds cubed to get meters per second? Okay, that's what you need to ask yourself, okay? Well, clearly I need to get rid of the s cubed because here I have an s on the bottom. Okay, so I'm going to actually have to divide that by s to the 4. 3 of those s's are going to cancel out with this, leaving 1 in the denominator for here. Okay, I need a meters on top, so I'm going to need an m here. Okay, on the right side, I have s, just seconds. So then again, ask yourself, what do you multiply by seconds to get meters per second? Okay, well, first of all, again, you've got seconds in the denominator. So to cancel that out, I'm going to put seconds squared because one of those seconds is going to cancel out with this, leaving 1 in the denominator. Okay, just like the previous one, I need meters on top. So there I go. Okay, so if you actually go ahead and cancel those out, you're going to see the 4 here becomes a 1 when it cancels out with those 3 s's there. Okay, leaving you with meters per second. And here, one of those s's cancels out with this, leaving you with meters per second. Therefore, okay, you can see, so b, if we put in meters per second, okay, to the 4, and then multiply that by s cubed minus meters per second squared multiplied by s, just like I showed in the previous step, everything works out, right? And in case you didn't see it before, here you go, the s cubes leaves 1s here, okay? This s also leaves 1s here, okay? So leaving you with meters per second minus meters per second, okay? So therefore, the dimensions, or the dimension of b is meters per second to the 4, and move this up a little bit, and the dimension of c is meters per second squared. Okay, so again, all it comes down to is looking at what you have, what you're trying to achieve, and what you need to multiply by in order to achieve that. Okay, so I hope you guys like this video. If you learned something from it, be sure to give that like button a click. Okay, and subscribe to the channel so you never miss a video from me. If you know someone who can be benefited from watching this, be sure to share it with them as well. And otherwise, I'll see you guys later.